Hi friends, in this video we'll discuss about the chapter work, energy and power. It's a grade 11th physics chapter and basic classes also like grade 9th and all you might go on through this chapter. We'll discuss here major concepts and the equations of the chapter which will help you to face the competitive examination easily. So please follow this video. I hope all of you will note down the concept important also. In this chapter, the major concept is what is work, types of work, how to calculate the work done by different forces, either a constant force or a variable force. Then we'll come to the terms energy, the types of energy like kinetic energy and potential energy. Then we'll come to power. And an important topic, collisions, the last topic. So these are the chapter structure, so we can discuss one to by. What is work? First of all, work is a scalar product of force and displacement as a theoretical definition. And you can say whenever you apply force on a body and there is a displacement in any direction, it can be, then we'll say a work is done on the body. So here work is equal to W F dot S. F is a force acting on the body and S is the displacement produced. Any angle it can be. So A dot B is AB cos theta, you know. So W is equal to Fs cos theta. What is the meaning of this cos theta component? Just we can analyze like this way. Suppose a body is on this a force F is acting. And the body displays along this way, make an angle theta with the horizontal, the direction of F. Then here S cos theta is the projection of the vector displacement along the direction of force. So this S cos theta acts as a projection of displacement along the direction of force. Same way we can write this as S into F cos theta also. That is the projection of force along the direction of displacement. So comparing the concept of projection, you can elaborate the concept of work. So for the calculation purpose, theta is the angle between force and displacement. In meaning we can say, so Fs cos theta. Here, if this theta is 0, that means the body is moving along the direction of force, then the work will be positive. You know, cos 90 is 0, work will be 0 then. That means if force and displacement are perpendicular to each other, it happens in many cases. Like in a circular motion, the centripetal force is always along the center and the body's displacement will be a tangent to the circle. Their force and displacement are perpendicular, so net work done is 0. So the work done by a gravitational force on a planet revolving around the sun is 0. And if a body is moving perpendicular direction of the applied force, then the work done will be 0 again because the theta becomes 0 there. So we can have a 0 work and a positive work. Now if theta is more than 90 degree and obtuse angle is there, cos theta will be negative, then work will be negative. So work can be three ways: positive, 0 and negative. With the example of gravitational force, if a body is thrown upward, the gravitational force acting downward. So work done by the gravitational force on the body moving upward is negative, because the angle, they are anti-parallel, angle is 180 degree. Work can be this many types: 0, positive or negative. So this is all about a constant force we are discussing. Now if the force is variable one, then the work done by a variable force W is equal to, you have to integrate concept. So integral f of x dx. If force is given as a function of position, with respect to position the force changes, then we have to use this concept, initial position to final position, f of x dx. Now if this work done by this variable force, if it is in a closed loop, like x1 is equal to x2 and the work is 0, then that force is called conservative force. Our gravitational force is a conservative force, and one spring force is there. If you stretch a spring along a distance x, then the force acting will be a conservative force. So if the work done by a force in a closed path is 0, then that force is known as conservative force. Or the work done by the force do not depend upon the path followed. then the force can be termed as conservative force. Spring force and the gravitational force is an example for it. That's about the work done. Now, the work done by a body on a body, another body. Suppose the force is applied on a body so that the body moves in a distance. We'll say a work is done on the body. This work done is equal to the kinetic energy of the body if the body moves. Kinetic energy K is given by half mv squared. It is the energy possessed by a body by virtue of its motion. K is equal to half mv squared. M is the mass of the body, V is the speed of the body. Here in this, clearly kinetic energy is directly proportional to square of the speed. So if you double the speed, kinetic energy become 4 times to the square, and it's directly proportional to mass also. You know the momentum, linear momentum P is equal to m into V, mass into velocity. Here also we get mass into velocity. So you can link kinetic energy and momentum like this way. P square by 2m is equal to K. So if this many percentage of momentum is increases there, what will be the percentage increase in kinetic energy? Or momentum is doubled, what will happen to kinetic energy? Like this question can come. So there you have to link this momentum and the kinetic energy. This momentum P is equal to root of 2mk. You can use it. So where K is the kinetic energy, M is the mass of the body, and P is the linear momentum. Okay, so I hope you got this link between kinetic energy and the momentum also. Now, another 2 types of energy, the elastic potential energy and gravitational potential energy. Before that, kinetic energy I told you, the kinetic energy, change in kinetic energy will be equal to the work done by a body. So work done on the body by an external force. So if a body is applying a force on another body and that body moves, second body, that means a force is applied on a body, so the body moves, then that work is done will be equal to change in kinetic energy, final kinetic energy minus initial kinetic energy. That's called work energy theorem. So if in a question mass is given and speed is given, initial and final speeds are given, you can find the change in kinetic energy, that will be equal to the work done. So work done is equal to change in kinetic energy, or change in kinetic energy is equal to work done. That's a work energy theorem we can have. Elastic potential energy. If you stretch a spring, then the work done to stretch is against the spring force is stored as the potential energy of the spring. That is equal to half kx square, where this small k is called a spring constant of the body, of the spring. So k is given by spring force by displacement, F by x. This F is a spring force. Half kx square will give you elastic potential energy. Now, against the gravitational force, if you lift any object to a height h, then there will be gravitational potential energy. U is equal to mgh, mass into acceleration into gravity into the height to which it is lifted. In these 2 cases, the work done against the spring force or work done against the gravitational force are converted to as energy. So work is equal to energy, we can say. In both cases, the work done do not depend upon the path followed. If you lift any object straight away or in the curved way or in through a staircase, anywhere like that, different methods you lift it, finally on the potential energy you have just check the vertical height only. So h you have to consider. Potential energy is directly proportional to height. That way we get the gravitational potential energy. So the concept of energy, mainly in this chapter we do 2 energies, kinetic energy and potential energy. Potential energy have 2, elastic potential energy and gravitational potential energy. I hope you got these concepts. So these equations you have to utilize here. So in this one, suppose from another one height to another height is given, h2 minus h1 you can use. One position to another position, x1 and x2 is given, x2 square minus x1 square you can use it. So difference in energies also you can find out. Now what is power? Power is rate of work done or rate of consuming of energy. Work by time or energy by time is called power. Mechanical power. If a object is doing this much of work in a particular time, then we can get the power, basically work by time. Here, instantaneous power, P is dw by dt, rate of change of work, differentiation if you do. Then work is force and displacement, so we can write as F dot V, the speed you can write. Because here d by dt of F dot S That is the power. So ds by dt is velocity. So F dot v, product of force and velocity or speed will give you the power. It's a scalar quantity again. So work, energy and power, all these three are scalar quantities. The SI unit of work and energy both are joules, and for power it is watts. It can be different levels, milliwatts or kilowatts, like that it can change, doesn't matter. So please make thorough with these concepts. Work, energy and power. Now, one term, collision, is the end topic of this chapter. Collision actually gives you a concept between interaction of two bodies. That means if two bodies are moving in such a way that speed of one is greater or less than the other one, then there can a chance of collision between them. During collision, a body applies a force on second body, the second body also applies a force backward. Action, reaction also will be there, and transfer of energy also can be there. If in almost all the collisions, the total momentum is conserved if there is no external force is acting. And if there is a conservation of energy also takes place, the kinetic energy, then we will say that collision is elastic collision. So collision can be two types, elastic and inelastic collisions. If both momentum and kinetic energy is conserved, that collision is called elastic collision. So before collision, if the body is moving like this way, u1 and u2, if u1 is greater than u2, they will collide, and after collision their velocity is v1 and v2. Then to get final velocities, we can have these two equations. Final velocity of first body will be equal to m1 minus m2 into u1 plus 2m2 u2 divided by m1 plus m2. And final velocity of second body v2 is equal to 2m1 u1 plus m2 minus m1 into u2 by m1 plus m2. So by using these two equations, you can find the final velocities in elastic collisions. So the velocity of approaching, if it is u1 minus u2, and velocity of deapproaching, their separation, v2 minus v1, then their ratio is called coefficient of restitution. Coefficient of restitution E is equal to v2 minus v1 by u1 minus u2. By analyzing the value of E, we can say whether the collision will be elastic or inelastic. Even a perfect inelastic collision, that means kinetic energy is not conserved, is lost. It can happen when two bodies stick together after collisions. One question can come like this way: both bodies stick together after collision, then that is not elastic, that is inelastic collision. We call it as a perfect inelastic. In this case, the after collision, both bodies stick together. V is equal to m1 u1 plus m2 u2 by m1 plus m2. Perfect inelastic collision. So elastic means both momentum and kinetic energy is conserved, and inelastic means only momentum is conserved, kinetic energy is not conserved. Perfect inelastic collision means after collision they stick together. In this one, suppose a ball is dropped from a top height h1 and it hit on the ground and it rebounds back to a height h. Then coefficient of restitution E can be written as v by u or root of h1 by h. Rebounding of ball is another significant topic in this one case, coefficient of restitution. There also interaction happens there. So in this topic, in this video, we discussed about work, types of work, energy, the kinetic energy and potential energy, then power. The relation in between also we discussed, and now collision, elastic and inelastic collision. Hope you watch the video thoroughly. Please make the short notes and prepare well. We can do some numerical questions like this way. A question is like this way: a bullet of mass 10 gram leaves a rifle at an initial velocity of 1000 meter per second and strikes the earth at the same level with a velocity of 500 meter per second. The work done in joule for overcoming the resistance of air will be. That's a question. 4 options are given there. So in this question, we have mass of the bullet is given, m is equal to 10 gram. You have to convert to kilogram, that is 10 into 10 raised to minus 3 kg. 1000 gram is 1 kilogram. So minus 3 you have to multiply with. And initial speed is given and the final speed is given. V1 is equal to 1000 meter per second and V2 is given as 500 meter per second. it strikes the earth with. Now what is the resistance of the air, will how much work will do? So here two velocities are given and mass is given. We have to use the work energy theorem to find this work done by the resistance of air. For that we can use the concept W is equal to change in kinetic energy delta Ke. So that can be written as is equal to half into 10 into 10 raised to minus 3 into. So it will be a negative resistive force. So V1 square minus V2 square will come. So 1000 square minus 500 square. The answer will be, if you resolve it, answer will become 3750. That much joules the work done will be. So here by reading the question you can get the idea that the resistance, air resistance, against that how much work should be done. So there will be change in kinetic energy of the body, because it loses the velocity from 1000 to 500. So kinetic energy changes there. That difference will be equal to the work done. I hope you got it. One more question we can check it like this way. A position dependent force F equal to 7 minus 2x plus 3x square, that means Newton is given, acts on a small body of mass 2 kg and displaces it from x equal to 0 to x equal to 5 meters. So xi is equal to 0 and x2 is equal to 5 meters. The work done in joule it is. So here mass also given 2 kg. The mass is given of the body. Now you know that variance force work done is equal to x1 to x2 f of x dx. So you have to integrate this function with respect to x. That is equal to integral 0 to 5 7 minus 2x plus 3x square dx will become like this, is equal to, if you integrate this one, 7x minus 2x square by 2 plus 3x cube by 3 from 0 to 5, initial to final velocity. The positions 0 to 5 you have to keep it. So this will become almost is equal to, you apply the upper limit and then lower limit. So it will become 7 into 5 minus 25, 5 square will come, plus 5 cube is coming 125, minus 0 will come if you substitute it, and its answer will be final answer. Okay, that's the work done in this case. So here we done the variable force F is given, then you have to find the work function as a variable force is there. So integration we done and we used it. Okay. Another question says like this way: the potential energy of a long spring when stretched by 2 centimeters is U. If the spring is stretched by 8 centimeters, the potential energy stored in it is. So this is the question. You have U is equal to half kx squared. So this U is directly proportional to square of the displacement produced. In the first case, we have to find actually in 8 centimeter if you stretch, what is the potential energy? So U2 is proportional to 8 square and U1 is proportional to 2 square. So U2 by U1 is equal to 8 by 2 whole square. So that is nothing but 16. So U2 is equal to 16 into U1. That is, we are getting 16U. So here is directly proportional to square of the distance. I hope you got this question. So please thoroughly follow these topics and prepare well. The worksheets will be attached with the video, so you have to solve that also with keys will be given. Thank you for watching.
Bright Education Center, Medical and Engineering Entrance Coaching Center, Hilal area, Doha, Qatar. For further enquiries, contact 306000679.